Okay, here we're going to take a look at equations of ellipses. Okay, so the question here says, please state the center, vertices, and covertices of the following ellipse. Now the equation for this ellipse is a pretty difficult one. It's going to need some manipulation. It's going to need some manipulation because it's in fact not in this form down here that we have. This is the standard form of an ellipse. And we want to notice the key part of the standard form of the ellipse, I think, is based around this idea right here and this idea right here. The fact that we have these perfect square quantities. Well, if we look in the original equation, nowhere do we get a perfect square quantity. There's no parentheses that are squared. Okay? But if we look a little more closely, we'll see that we kind of have the pieces of them. If we have a 9x squared and negative 36x, maybe they can be grouped and manipulated to become this term right here. And maybe, if we notice that we also have this 16y squared term and negative 64y term, maybe they could be grouped and manipulated to become this term right here. So it's kind of a long foresight that you have to have for moving the given equation into the standard form. So the first thing I'm going to do is say to myself, well, if I can move to that form, maybe I could use that great complete the square tool. Maybe that's what's going to move me from one form to the next. Okay? So to start this problem, I'll just try and do a couple of basic things to start. The first thing I'm going to do is I'm going to move some terms around so that it's a little more friendly looking, the problem. Okay, so the only thing I did so far was move my x terms together, move my y terms together, and then I added 44 to both sides of the equation to move the 44. Okay, move is not the best word to say, but that's what it kind of looks like it did. Okay, now that being said, what I want to do is I want to take these two terms and factor them. And then I'm going to take these two terms and factor them as well, because they have a common factor inside them. So for the red part that I have underlined, we see that 9 goes into both of those two terms. So I'm going to write 9 times the quantity x squared minus 4x plus, then the purple part is going to be, I think 16 goes into both of those terms. So I'm going to factor out the 16 and get y squared minus 4y, and then I'll pull down my equals 44. Okay, now don't get too confused here, because we see now, oh yeah, I've got a set of parentheses and I want to move it into a set of parentheses like that, so I must have it already. Well, it's not actually in that form just yet, because if you notice, this term right here is a perfect square, and these set of parentheses up here is not. Okay, well, that's a lot of talking around this issue. Hopefully you're going to see that I'm going to write 9 times the quantity x squared minus 4x plus something that I'll name later. Okay? Then we're going to go with plus 16 times the quantity y squared minus 4y plus something that I'll name later. And then it makes sense to say that it's equal to 44. But I guess if I'm going to add something on the left side of the equation where that green mark is, I better do it on the right. And similarly for that blue mark, I better do it on the right side of the equation too. Okay, so if you've caught on now, what I'm trying to do is a skill called complete the square. Because I know that if I can take a perfect square trinomial, I could factor it into this. And if I could take this and create a perfect square trinomial, I could factor it into this. Well, that would be great. Okay, the question is, what do I add on the green line and what do I add on the blue line to create that perfect square trinomial? Well, to do that, the trick is pretty simple. I take the middle term, cut it in half, and then raise it to the second power. So when I do that, I'm going to cut the negative 4 in half, get negative 2, and then I'm going to add 4. Okay? So now a lot of people would think that over here on the green line, I add 4. This is not correct. If you think and look very closely, you're going to realize it's because you did not really add 4 by putting that 4 there. You added 9 times 4, which is in fact 36. So I'm going to add 36 to the right side of the equation. Okay, now similarly, what do I add on the blue line? Well, it's going to be the same trick. I'm going to cut this negative 4 in half and then raise that to the second power to find what goes on the blue line. That is just the trick that does it. It creates a perfect square trinomial. So when I cut the negative 4 in half, I get negative 2 again, and then when I square that, I'm going to get 4. So again, a lot of people would think, oh yeah, I added 4 so on the left side, so add 4 on the right side. This is in fact not true, because you did not add 4. You actually added 16 times 4, which in fact is 64. Okay? So from there, I now have a great situation because I have a perfect square trinomial here, a perfect square trinomial here, and they can be factored into the square of a quantity. So let's actually attack that now. So I'm going to get 9 times a quantity, x minus 2 squared. I get that by factoring. So you have to have the skill of factoring to be able to move forward from the previous line to the line I'm writing now. So plus 16 times the quantity, y minus 2 squared. And that, in fact, is going to be equal to 144. Okay? Now, it's starting to look a little bit more like this, except you notice I don't have any denominator, and it's not equal to 1. It's equal to 144, this equation. Well, the good news is I can actually divide both sides by 144, which means I'll divide both terms on the left by 144, and I will write the result of that, which is going to be x minus 2, the quantity squared, over, excuse me, so we're going to get that to be over 16 plus, simplifying this fraction, y minus 2 squared over 9, which is equal to 1. So in one fell swoop now, you can see we actually turned this equation here into the appropriate standard form by doing that division by 144. Okay, now from here I can identify the center of the ellipse, which is h comma k, which is, by the rule that we said, the opposite rule. Just look at the opposite of what you see here. Okay, I see negative 2, so it's going to be 2, comma, and then what's the opposite of what you see here? Well, I see a negative 2 there, so the opposite of that's going to be 2. And to determine a, I'm going to look here and realize that 16 is equal to a squared, so a must be equal to 4. And then I'm going to look here and see that 9 must be equal to b squared. So b is equal to 3. So I see from there that, extend the page here a little bit, that the general shape of the ellipse, it should be wider than it is tall. So the major axis is going to be the horizontal axis, and the minor axis is going to be the vertical axis. So the vertices will be associated with A, and the co-vertices will be associated with B. Okay? So I'll manipulate the value of H by adding and subtracting 4 to it. Okay? And I'll manipulate the value of K by adding and subtracting B to it. Okay? And when I manipulate the value of H, K will not change. So what I'm going to do is I'm going to do 2 plus 4 is 6, comma 2. And 2 minus 4 is negative 2, comma 2. Those are the vertices. And to get the co-vertices, again, they're going to be on the shorter axis. Okay? And that is going to be in the up and down direction, I need to think. So I'm going to manipulate the y. So I'm going to get 2 comma 2 plus 3 is 5. And then I'm also going to get 2 comma 2 minus 3 is negative 1. Now, if I had a piece of graph paper, I could sketch that out and label those points. And with a center of 2 comma 2, you would see that I would get an ellipse that, in fact, is wider than it is tall, because the major axis, again, is in the wide direction. So to review here, there's a lot that goes on in this problem, okay? But the major portion of what you need to see is that you cannot get from this first line to the standard form of an ellipse without completing the square. It's kind of a magical tool that we use to take such an ugly equation and put it in this standard form. So feel free to watch this over again. You know, the hardest part is realizing that you're going to have to factor in both of the expressions that involve x and y, and then you're going to have to complete the square by some type of addition, but you have to watch that multiplier on the outside when you balance the equation on the right side. This happened twice in this equation. It's one thing to know that you can complete the square with a 4. It's another thing to see that you did 16 times 4 on the left side of the equation and then add 64 on the right side of the equation. So this takes some practice and seeing some examples, so you might want to take another look at this. I'm sorry this was long. I tried to go slow, so hopefully this was helpful.